In this video, we are going to discuss few problems on convolution theorem. First problem is using convolution theorem, find L inverse of s square by s square plus a square into s square plus b square. Before we start to solve this problem, first you should know about statement and definition of convolution theorem. This is the statement of convolution theorem, which is L inverse of f of s into g of s equal to, we can write L inverse of f of s star L inverse of g of s. And also the definition of convolution theorem is f of t star g of t equal to, we can write integral 0 to t f of u into g of t minus u into du. You should remember these two equations. First one is statement of convolution theorem, second one is definition of convolution theorem. Now we can solve this L inverse of s square by s square plus a square into s square plus b square equal to, we can write L inverse of s by s square plus a square into L inverse of s by s square plus b square. Here we used statement of convolution theorem, L inverse of f of s star L inverse of g of s form. And also here we can apply L inverse formula. L inverse of s by s square plus a square is cos at. L inverse of s by s square plus b square is cos bt. Both are same, but here constant terms will be different. Here a is there, here b is there. Otherwise both are cos formula only. Cos at star cos bt. Now we are going to apply here convolution theorem definition, f of t star g of t definition. Here cos at is like f of t, cos bt is like g of t. Cos at into cos bt equal to, we can write integral 0 to t. What is our right hand side term in the convolution definition? Integral 0 to t f of u. Left hand side f of t means right hand side we are writing f of u. Here cos at is there. Cos t is like f of t. In the place of t, replace by u. Cos au, first term, right? Cos au. In the second term, g of t minus u. Left hand side g of t is there. Right hand side we are writing g of t minus u. In this problem, the second term is cos bt. That is like g of t. This can be written as cos of b into t minus u. In the place of t, you replace by t minus u into du. Here we applied convolution theorem definition. Now we are going to integrate with respect to du. But we cannot integrate directly because there are two terms here. First term is cos au into cos b into t minus u is the second term. We can't integrate directly, but with the help of two cos a cos b formula we can integrate easily. We know that the formula 2 cos a cos b equal to cos of a plus b plus cos of a minus b. Apply this for 2 cos a cos b formula here. Here a is capital A is au, b is b into t minus u, that is bt minus bu. The whole term will be like capital B. Now this apply this formula here. In the formula 2 is there, here 2 missing, that's why we can write here 1 by 2. 1 by 2 into integral 0 to t cos of a plus b. A is au, written here, a is au plus b is bt minus bu, written here, plus cos of a minus b. A is au, capital A, minus b, bt minus bu. Here one negative sign is there, that's why we written here plus. In the formula also here one negative sign will come, it will be positive, plus bu into du. Before we integrate with respect to u, simplify this one. 1 by 2 into integral 0 to t cos of, from the first and last term taking outside common u. Here u common means we will get a minus b into u plus bt plus cos of, from the here in the second term also from the first and third term taking outside common u, which is a plus b into u minus bt into du. Now we can easily integrate with respect to du. Integral of cos is sine. Now we can write 1 by 2 into sine of a minus b into u plus bt divided by a minus b. This a minus b is nothing but coefficient of u. A minus b is coefficient of u. That's why we are writing in the denominator. Plus the second term, again integration of cos sine of a plus b into u minus bt divided by a plus b. The coefficient of u is a plus b right here in the denominator with the limit 0 to t. Now we are going to apply the limits. First apply upper limit value t in u. Upper limit value is t. 1 by 2 into sine of a minus b into t. What is t? Into t. In the here u is there. First you substitute u is equal to t here plus bt divided by a minus b plus sine of a plus b into u. U is t here. Substitute here into t minus bt divided by a plus b minus sine of bt, which means now we are applying the lower limit value 0 here. Substitute here u is equal to 0. The first term this becomes 0. Only we are getting bt, that is sine bt. Minus sign, after applying the upper limit value, we have to add one negative sign here, which is minus sine bt divided by a minus b. And then apply the lower limit value 0 in the second term also. Sine of a plus b into 0, which means the first term this becomes 0 minus bt, which means sine of minus bt is minus sine bt. In the lower limit one negative sign will come, that is positive, which is sine bt by a plus b. We applied both upper and lower limit values here. Now we are going to simplify this one. 1 by 2 into sine of this t is common for both a and b. Multiply with this t. At first term, the second term will be minus bt plus bt divided by a minus b plus sine of at plus bt minus bt divided by a plus b. Third and fourth term will be same. Now 1 by 2 into sine of, here bt opposite sign, we can remove these two terms, sine at by a minus b plus the second term also bt opposite sign, we can remove these two terms and then we will get sine of at divided by a plus b, and then third and fourth term will be same. Now from the first and second terms, taking outside common sine at common from the first and second terms. Sine at common means rest of the terms here 1 by a minus b will come, and this next term 1 by a plus b is there. As well as in the third and fourth term, from these two terms also taking outside common minus sine bt, and then minus sine bt common means here we will get 1 by a minus b minus 1 by a plus b, because minus into minus plus. Now 1 by 2 into sine at into, now taking cross multiplication for these two terms, we are getting a plus b plus a minus b. This term goes to here, this term goes to here. A plus b plus a minus b divided by a plus b into a minus b. A plus b into a minus b is a square minus b square. We know that the formula a plus b into a minus b is nothing but a square minus b square written here. In the second term, minus sine bt into, taking cross multiplication here also, a plus b minus of a minus b, that is minus a plus b divided by a plus b, a minus b into a plus b, that is a square minus b square. Again we used this formula here. Now here these two b's are opposite sign, we can remove these two b's. In the second term also, here a opposite sign, a cancel, and then we can write 1 by 2 into sine at into a plus a 2a into sine at by a square minus b square, minus here 2b will come, 2b into sine bt divided by a square minus b square. Now look at this, both the denominator values are same. Now we can add the numerator term directly. Here 1 2 common, from these two terms taking outside 2 common, already we are having here 1 by 2, 2 2 cancel, We are getting a sin at minus b sin bt divided by a square minus b square, which is the final answer. Okay. The next problem is, using convolution theorem, find L inverse of s by s square plus a square whole square. As I told you before we start to solve this problem, first you should know about the statement and definition of convolution theorem. This is the statement of convolution theorem. L inverse of f of s into g of s is equal to L inverse of f of s star L inverse of g of s, and also written here definition of convolution theorem. Okay, our given problem is L inverse of s by s square plus a square whole square equal to, we can write L inverse of s by s square plus a square one term into L inverse of 1 by s square plus a square another term. And now apply L inverse formula here. L inverse of s by s square plus a square is nothing but cos at we applied here. In the second term, in the numerator, constant term 1 is there, which means one of the sine formula, but here a missing in the numerator. That's why here multiply and divide 1a. 1 by a into 1 by a into L inverse of a by s square plus a square, which is sine at. 1 by a into sine at. Okay, which is in the form of f of t star g of t. Okay, now we are going to apply convolution theorem definition, which is equal to, we can write written here, f of t star g of t equal to integral 0 to t f of u into g of t minus u into du. Apply here. Here cos at is like f of t, sin at is like g of t. 1 by a constant, take outside, 1 by a into integral 0 to t cos au. Here replace t by u in the first term. In the second term, replace t by t minus u, sin of a into t minus u into du. Right here, first term sin term, in the second term cos term. We can, because why we are going to apply here sin a cos b formula. That's why we are writing in this form. 1 by a integral 0 to t sin of a into t minus u is the first term into cos of a u is the second term into du. For our convenient purpose only, we written in this form. This term first, the a u is the second term. Now we are going to integrate with respect to du, but we can't integrate directly. With the help of 2 sin a cos b formula, we can integrate easily. 2 sin a cos b formula is sin of a plus b plus sin of a minus b. You should remember this formula. Okay, here sin a is at minus au, capital B is au. Okay, apply this formula here. 1 by 2, because here 2 missing, that's why we are taking here 1 by 2. Already we are having here 1a, which is 1 by 2a integral 0 to t sin of a plus b. A is at minus au plus b is au. Here au opposite sign, we can remove these two terms, plus sin of a minus b. A is at minus au written here, minus b is au written here into du. Now before we integrate with respect to du, simplify this one. 1 by 2a integral 0 to t sin of at written here, sin of from these three terms taking outside common a common means we will get t minus u minus u, a into t minus 2u. Right here, a into t minus u into du. Now we can integrate easily with respect to u. 1 by 2a integral of sinus cos, we know that, but in the first term sin at is constant only. Sin at into u will come, minus integral of sinus minus cos of a into t minus 2u divided by minus 2a, because the coefficient of u is minus 2, and also here one a is there, which is minus 2a, with the limit 0 to t. Now we are going to apply upper limit value t in u. 1 by 2a into t into sin at plus substitute here u is equal to t, which is t minus 2u, which may t minus 2u is there, u is t here, which means t minus 2t, which is minus t. Anyway, cos of minus theta is cos theta. We will get here cos t only. We will get here cos t. Already we are having here one negative sign. Here one negative sign is there. Here one negative sign is there, which is positive. We will get cos of at here divided by 2a. And then apply lower limit value 0 here. Substitute here u is equal to 0. The first term becomes 0. The second term also substitute u is equal to 0, which means we will get cos at divided by 2a. This negative sign is common for both. In the next term, 1 by 2a t into sin at plus cos at by 2a minus of cos at by 2a. Here cos at by 2a, cos at by 2a opposite sign, we can remove these two terms. We are getting now t into sin at here. Outside we are having 1 by 2a, which is equal to, we can write t by sin at divided by 2a, which is the final answer. That's all.